Today we are back with a new topic, that is microservices architecture in our backend architecture series. So in this microservices architecture, we are going to learn how microservices architecture works and how we design the project folders in microservices architecture. In short, we are going to see all the flow of services that we use in a microservices architecture, how we design those services, what are the advantages of microservices architecture, what are the disadvantages of microservices architecture, and everything. So this video is going to be a real fun. So as we go towards, let us discuss first how we design the folder structure of a microservice that we are going to use in our microservices architecture. So firstly, when we are going to design a service, we design that service in a n-layer architecture. Uh, that service should contain multiple layer. That is controllers layer, services layer, models layer, repositories layer. So these are we call something we called as n-layer architecture. And one service contain one for you can say that one service having one is deployed independently, and other service is deployed independently, and they are independent of each other as well. They are independent of each other, they have their own databases, right? This thing you have to understand, that they have their own databases. It is not compulsory that you can use shared database as well, but we prefer to we prefer to maintain individual database of each service. Okay, so here the what is n-tier architecture, what is controller, as I have discussed in earlier video as well, that is in monolithic architecture video. Controller manage and controls the flow of services and models everything. I mean, controller examine everything, and controller is the front face guy that handles all the requests. Then we have services. Then services contains some business logic, like what your API is actually performing. That logic is written in services folder or services classes. Then models contains all your replica of database table. That is, it contains the information of your whole database table. Okay, then we have repositories. I think the spelling is wrong, but repositories contain all your database related transactions that you are going to perform with database. So all these things combinedly we deployed as a service, and this service act as independently. For example, I have taken an example of a e-commerce application, and this is a payment service, and second one is a order service. So I hope everything is clear until now. Then we have discussed what a service contains. Let's see that payment service is interacting with order service, and I have taken again one example of order service as well, and I will explain how these services interact with each other in a microservices architecture. This thing is important. Microservices, we are talking in this video about microservices architecture, right? So how this microservices interact with each other, I have explained I am going to explain in this diagram. So first thing, when a client initiates a request, usually these microservices interact with each other through HTTP or gRPC. gRPC is fast, developed by Google. So currently many microservices use gRPC, but many of them use HTTP protocol as well. So as they usually let's consider HTTP. They interact usually with HTTP protocol. First, client initiates a request, then the request goes to API gateway. Then API gateway will decide on which service I have to forward this request, right? So API gateway first forward the request to the desired microservice, right? So it will transfer that request to desired microservice. So for example, client want to see his payment history, so this API gateway will transfer his request to the payment service. If client wants to log in, then this gateway will transfer his request to the login page, right? But the magic here is not API gateway, but here the magic is these microservices are interacting with each other independently, and they are deployed also independently. So if one microservice is down, other is live, other delivery service is live, payment service is live, even the authentication service is down. So your whole application is not down, right? So here, API gateway is used to transfer or forward the request from client to other microservices, right? But the flow is not directly okay. So I will explain how it works. So then the request goes to auth service. So for example, say client wants to log in. So this request goes to auth service. Then auth service wants to interact with payment service. For example, if it wants to interact with payment service, so the auth service will not directly go to the payment service because they are independent. They don't know what is the URL of next service or where it is deployed. Okay, they don't have that information because the security reasons comes in. So this auth service will firstly interact with this service registry. Service registry is the component that stores all the information related to your services. What is the URL of services, name of the service? Okay, so auth service want to interact with payment service. It know that I want to interact with payment service, so it will goes to service registry. He will say that I want to interact with payment service. Give me its URL, give me its port where I will interact with that service. Then service registry will return that URL and port of the payment service, and then auth service will successfully ready to interact with payment service, right? So in this way the flow works just like that. If here it is written that verify user before payment, so auth service uses payment service to verify user, and many more. Here it is written that trigger delivery after payment. So delivery service will trigger the delivery if the payment is successful or not. So in this way, the whole interaction happens in the real time architectures. So now you got the understanding of how the architecture interacts with each other. So now this is called service oriented architecture also. In some books you will see that it is also called as service oriented architecture. It basically means that they are talking about microservices architecture. That is the fancy name, or it is the fancy name of the same thing, but they both are the same thing, right? So this service registry can also somewhere called as service discovery as well. And service registry and service discovery it is the same thing, right? So don't get confused. Then let's talk about advantages and disadvantages. So when we are talking about advantages first, so microservices architecture comes with huge scalability. You can scale the service that have the most traffic. So if your delivery service is having the most traffic, like in from 10 o'clock to 1 o'clock, I guess your delivery service is having most of the traffic. So you just increase the containers or the servers of your delivery service, and you just keep all the auth service and payment service same. That will reduce your cost, and it also improves scalability. Okay, and you can also use load balancers as well to distribute traffic evenly. Then the next advantage comes is fault isolation. So because services are independent, right? So their fault tolerance comes in because the security increases as the services are independent with each other. So they are not, the whole application is not easily hackable, or you can say it eventually increase the security of these services, right? Then we have independent deployment. Independent deployment, according to me, is the best advantage of microservices architecture, because when services are deployed independently, even if one service is down, whole application is not down. That is the whole point, right? So that's the main advantage of microservices architecture. Then we have tech freedom. Tech freedom means if one team, let's suppose five people are working on auth service, and they are comfortable with JavaScript or Node.js, like Nest.js, okay, Nest.js, 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 then they can work in auth service with Nest.js. And if the team two with five people, they are comfortable with Spring Boot, Java Spring Boot, then they can work on Spring Boot as well. So there is not a language or technology barrier. So that's the main advantage of this architecture, that your teams are not dependent on a particular language, right? So tech freedom is also there because these applications are going to be deployed independently. So there is not a issue of a language. Then we have better testing. So your whole application is not contained or inside a single folder. So everything is easily understandable, maintainable. So you can do better testing and apply CI/CD pipelines to each service. Okay, you can test this service independently, and you can better test it when it is independent, right? So you can test it independently, then you can test it independently, so it increases the testing of these services and authenticate what we say, uh, correctness of testing, right? Okay, correctness is the correct word. Correctness of testing. Your testing will be fine if these services are independent. Okay. Next we have better testing and CI/CD. You can CI/CD means you can apply all the actions that are that you want to perform in this service. When you deploy this service, all actions, that is building, testing, deploying, containerizing, everything you can apply in CI/CD and to each and every service independently. You don't have to manage whole application all once. Okay, so these are some advantages of microservices architecture. Yes, there are various advantages as well, but I have taken 5 advantages that I consider are most important. Then we talk about disadvantages. So first disadvantages is complex communication. What is complex communication? So you have to establish APIs between these services. So each service talk with other service through API. So you have to and you have to maintain this service registry as well. This service registry you have to maintain, and this services communication you have to maintain. So it will increase complexity. Are you getting my point? This will increase the complexity. Uh, then our second disadvantage is distributed debugging. So if any fault occurs in this microservice architecture, for example, fault occurred in payment service, right? If there is a bug in payment service, yeah, you examined all the code of payment service, but you didn't find any bug. It is possible that bug came from auth service or delivery service as well. Then you have to examine these services also, and finding and debugging in microservices architecture is a little bit hard if the fault is occurred from other services, right? So it is really hard, but this is not a case in monolithic application. Okay, then I think you understand it. Then DevOps overhead. So just like we talk in advantages that you can apply CI/CD pipeline to each service, so it increases your DevOps tasks, that you have to apply CI/CD pipelines to each service. Then you have to maintain those pipelines and everything. Then it means your DevOps task increases. And data consistency. Okay, just like you see here, each service have its own database. Okay, so each service is having its own database, means that there should be consistency in this database. It should not be like there is some other data. There is name Ujwal Hiranwar in this database as a user, but it is not reflected in this database because there is not consistency. It should not be like that. Every database should be consistent, and the data should be same in each and every database. Okay, so there should be consistency, and consistency is the biggest issue in microservices architecture. There should be consistency maintained. Okay, then we have inter-service security. There are various frameworks in very mature frameworks like Spring Boot for inter-service security, but the inter-service security means you are protecting each and every service with various things like multiple layers, or you can just like we used n-tier architecture, and there are various other things like Spring Boot has Spring Security. There are various other things in Nest.js as well, but I don't know that. But yeah, you can apply to security to each and every services through various ways. Then we have talked about disadvantages, advantages, and everything like folder structure as well. So this is service oriented architecture. This is how services come. I think API gateway is here. Okay, so this is how the services communicate through each other in real time. Client initiates a request, it goes to API gateway. API gateway decide which service I forward this request to. Then that service will communicate with okay, Control Z. Then that service will communicate to service registry. Then service registry will forward the address of the next service to the primary service. Then primary service like auth service can communicate to payment service or delivery service, that whatever it wanted to communicate. So this is how the architecture works. I hope you understand. Thank you for watching.